So my talk is titled Bulletproof Projects. And yeah, what is this about? It's more or less, I just tried, like with the DDD talk yesterday, I just tried to compile some things that I think are useful. There's not like any red thread that you can follow along the talk. It's just some random things, and I hope you still can take one or two things from this. I try to not cover the stuff that has been covered 10 years ago already, like PHP unit basics, but instead decided to bring some new stuff that I found useful in my projects. Yeah, so let's just start. You've probably seen that slide yesterday already. I do TYPO3 since quite a while. I recently moved to Cologne. I lived in Karlsruhe for quite a long time, and I used to be a hardcore coder, and recently, over the last years, shifted a bit to some more educational role, both in my daily job and also in the TYPO3 community, which is also why I now try to do more talks on these educational topics. So, bulletproof projects, why should we do that? And if you've seen my talk yesterday, you know there are a lot of memes. There are not so many in this one, but I think this is maybe the main thesis why we need to harden our projects. That code used to live for quite short time. We often threw stuff away and totally overturned everything with each iteration of a project, but I think that's currently shifting. The projects have an increasing lifespan, and there's also components that live longer because they are hard to create. The applications become more complex. We've got third-party integrations with APIs, for example, or directly connecting to other systems. And also TYPO3 is often not used as the only system, but it's part of a system of systems. Like you've got a CRM or an ERP, or I don't know, other enterprise systems in the mix, and all of that needs to be connected, which means the stuff gets harder to build, more expensive to build, and we need to harden the code that we write to make it live longer than, I don't know, 1 year. I would say the expected lifespan of code for integration into other systems is probably more towards 10 years than towards 1 year. And also the uncertainty in what we actually want or have to build has increased. So we need shorter experimentation cycles, which also means code is changed more often. So these are actually two trends that seem to contradict each other. We've got longer lifespan of the code that we create, but on the other hand, the cycles in which the code is changed get shorter, which in some means code changes more often, and on the other hand lives longer. So the big question is, how can we keep that healthy? The goals for me are make the artifacts that we create, the code that we create, also the stuff that we build, like, I don't know, front-end assets and stuff like that, more robust, make these builds more predictable, more reproducible, and also increase the lifespan of the stuff that is created, like especially the code. In other industries, if you see stuff like this, or if you see that happening, like for example in the construction industry, what usually is done is standardization, and also the creation of reusable platforms. And we're probably also on a path towards that, standardization with PSR and other things, and also the reusable platforms. Probably a bit too much wine yesterday. My tongue is a bit shaky. Reusable platforms is also something that I see in quite a few places. Probably not as a real effort to let's now create a reusable platform, but that's more something that comes more naturally. So the thing is, this all is probably a big effort, especially if you're a smaller agency. That's probably not something that you can just do in 1 or 2 weeks, or that's more a project for months or even years. So the question is, can we do something smaller? And that's actually what I want to show in this talk. Yeah, we can do that. So basically just start. I don't know how your individual workflows or what your workflows look like, but my experience is that you can easily add some small tools to the workflow, automate that workflow step by step, and reduce the manual labor that is necessary. And also for many things, there are already existing solutions that you can just get off the shelf, try them out, check if they work for you. And if you realize, okay, this deployment technique doesn't work for us because of X, Y, Z, then you can easily change it. But try to stick to standards first, because there are other people who have put a lot of effort into this. Stick to that first. So the question is where to start, and ideally just try to find your pain points. Sit together with your colleagues, check what is often, or why does stuff break, and what is stuff that we spend, or what are things that we spend manual labor on that we don't have to, like for example code formatting. Whoever formats code by hand today, just don't do this, because there are tools for this, and this is all automated, and it's something that you shouldn't have to waste any time on. And then try to find tools for these pain points, test them, check them, and if they in turn cause pain, then just drop them and try something else. I will present some tools today, but there's also other tools out there that might better fit your use case. The ones that I present are ones that I personally use or that I used in my projects, and that I found pretty useful. So I can recommend them. I probably don't have experience with other tools, but they might work better for you. Of course, as always, greenfield projects, if you start from scratch, there's more flexibility, you can try more stuff, but also in an existing project, it's often possible to slowly start and then later on get stricter with, I don't know, for example, code analysis. The important thing about all this, especially if you're an agency with a lot of projects, version your stack. That's something that I would always recommend, because otherwise you're going to end up with like a slightly different stack in every project, and that's just going to cause too much pain, because you always have small issues or smallish deviations between the different versions. And just try to have a clean definition of what is your stack from this year, the stack for next year, the stack for the year after, and also try to migrate to newer versions and keep the maintenance effort low. That's just some general recommendation. Okay, any questions up until here? Yeah.
Hello? Okay, it's okay. You said we should version our stack and upgrade it gradually.
Yeah.
So, if I have multiple projects with multiple versions of my stack, is it a good idea to make the upgrade in the other projects when I start a new project and have a new version of my stack, so that I upgrade also in the older projects? Or would you say it's not really a good idea and I wait for the older projects if I must do a greater upgrade in the older projects to upgrade also my stack there?
Depends a bit on what you do. If it's just if it's really a project that like you do once and then it sits for 3 years and then the customer comes and requests an upgrade, or you say you have to upgrade because the old version runs out of support, then I would probably leave it like it is. But this also depends on how much you change. For example, if you I don't know, if you just turn up the level in your static analysis tool, the PHPStan that I will present has different levels. If that's the only upgrade that the stack does, then you can just deploy it, because usually this helps in also finding hidden bugs, and that's something that is good. If, for example, you upgrade PHP unit to a new version and suddenly you, I don't know, need to change every test, then that's probably something that I would postpone. And it also depends on how much maintenance effort in general you can afford. If you suddenly have 20 versions that you have to maintain in parallel, that's probably too much. If it's just we have one version for the older projects, and one version for the current projects, and we're developing one for the new projects that we start in like a year, then that's probably fine, and you can gradually upgrade. And it also depends on how you do these upgrades. For example, I've seen with one client, not for their build stacks, but for their base machines. So they had one file with the version number of the operating system image that they use for deploying new services. And that was basically automatically updated all over the company. There was some script that ran over all repositories and created pull requests for each repository. And that's something that is easily maintainable as well. So that's something that I would recommend if you can automate in that way. Yeah.
Okay. Thank you.
Yeah. Any other questions? Good. Okay. So I basically have, there is lots of tools out there that you can use to improve code quality. Some are good, some are not so good. All depends on the use case. Some that I present are also not suitable for TYPO3 projects at the moment, but I hope that they will gain TYPO3 support, because I think they are tremendously useful. And this is also like some kick for me to start digging into that I present them now, and like make your mouth water, so that you want the tools, and I hope we can get them for TYPO3. Yeah, so the first category of tools is code analysis, both static and dynamic. I don't have any dynamic code analysis tools in here, but static tools are already a pretty good thing. And it's not like static is bad and dynamic is good. They're both equally useful for different purposes, just. Testing tools, like not PHP unit, but a bit beyond that, and also dependency checks. And I have a small chapter in the end on deployment things, but that's not so much tooling focused, but more strategy focused. That's why it's not on here. Yeah, so for code analysis, or what is basically static code analysis? Checking code without running it. So checking code with running it is, I don't know, manual testing or automated testing is one thing, or you can also do code coverage analysis, for example. That's a dynamic analysis technique, and static code analysis basically looks at the code, abstracted into some syntax tree. Computer science people know more what I'm talking about than I do. What this allows is, for example, finding bugs and security issues, and also stylistic issues with the code. The important thing here is there's not one tool. It's not like you have this static analyzer, you turn it on, and suddenly all the issues in your code will become visible, you can fix them, or it can even automatically fix them. There's different tools that have different purposes. My recommendation is just mix and match them as they fit your use case. Just try to not find two tools that do the same job and then contradict each other, because that's just fix the issues that the one found and then the other one breaks, and vice versa. This is just gonna give you dependency hell, or build hell, basically. So what can we find with static analysis? One big class of errors is syntax errors, just basic, is that valid PHP code or not? Then code formatting, which is something that should, in my opinion, be solved today, because there is the PHP CS fixer, and that's something that you just shouldn't do manually. code style, like for example maximum line length, maximum method length, number of methods in a class, which is where we're leaving this is pretty much defined, and go more into well, that's a recommendation and you shouldn't have longer lines country, because this is not some hard rule that you can have a hard rule, but it's more like a recommendation to keep code maintainable and keep code understandable, to not have methods with 500 lines, and not. This won't work. It will, of course, work from a technical perspective, but the code is not good, or is not well maintainable. Well, then there's actual bugs, like, for example, there is an assignment missing, so you're doing some computation and it just vanishes into the void. Wrong operators can be detected, like if you do an equals comparison and there might be some typecasting involved that then breaks. This is something that a static analysis can find, or missing parameters for methods, type issues, like there's a string expected, you pass a boolean and it's gonna break, and loads of other actual issue classes. There are quite some tools, and I'm going to show two. The one is PHPStan, the PHP static analyzer, and PHP CS fixer, which is also used by the TYPO3 core. And then there's others like PHPCPD, copy and paste detector, which is quite old. Yeah. Yeah, these are the two that I will cover. The asterisks are the two tools that I will cover. Yeah, there's PHPCPD, the copy and paste detector, which is a bit older and I guess more well-known, which is why I'm not going to cover it. And as well, pdepend, and the PHP mess detector, which are all tools that have been around for quite a while. And then there's another class of tools, dependency checkers, but more on that later. Because the situation there is not so nice if you're in a TYPO3 ecosystem. So PHPStan, the so-called PHP static analyzer, is a static analysis tool. Surprise, surprise. And the nice thing about it is it doesn't force you to rework all your code at once. Has multiple analysis levels. You can start at the lowest level, which is, I think, 0, and then get stricter over time. We also did that when we introduced it in a project, starting with the lowest or second lowest level, and then fix some issues that this detects. And then once there is time, get to the next level and also fix these issues. This actually detects a lot of issues, a lot of different issues, but of course sometimes there are false positives. Like it can't always detect the correct parameter type, so you need to annotate that, or the correct variable type. But my personal opinion is, though it's sometimes nagging and a pain in the butt, it actually in many cases forces you to rethink bad design and bad code design on a small scale. Like I don't know, you're doing a return where you shouldn't do a return, but instead collect the result and return later, for example. Or other things that are just small code smells that can accumulate over time in your code base. And if you just have someone who's constantly nagging you, this is bad, then you're not gonna, or the code base is basically gonna stay healthy. So one example that this actually found in one of my projects is I missed I basically did the wrong type annotation with both the class and object, which is wrong. I don't know who did that. I guess it was PHPStorm and not me. At least I'm gonna blame PHPStorm. And it actually, PHPStan then actually complained about the two usages of this or of a method in that class, event hydrator, that is not, of course, not present on object. And the same goes for all different kinds of other errors This is another example that we had in one project basically, where some type hints were missing, or some versions didn't fit together, and that would actually have broken in production, because we had an old version of one dependency. Apparently someone didn't commit the composer update or whatever, and therefore some class was not available that should have been available. It also detects loads of other things. Nice thing is, even if you don't want to integrate it into your normal workflow, you can just test it with some code that you just throw at the online interface on phpstan.org. So if you just want to see, okay, is that code good or not, just take an excerpt from your code and throw it at this web interface. Of course, it's not going to find, or it's going to find a lot of issues with dependencies because they won't be available. But just to get some rule of thumb on how good your code is, that's not bad. Okay, second tool, the so-called PHPCS fixer. And I personally think code formatting is not an issue anymore, because code should just be formatted for you. And I called that the end of all styling discussions. Just don't waste any time on code styling discussions. That's a solved issue. The TYPO3 core has a good configuration for PHPCS fixer. And the nice thing is it can not only find issues, but it can also fix them for you. So you can basically integrate that into your normal commit workflow, personal commit workflow, that you just let it run over code before committing. And then the CI pipeline will also be happy and not throw an error. So yeah, this is basically what such a run looks like. It checks all the files. Each file is one dot, and then you have some files that had errors, or actually in this case, the errors got automatically fixed. And you can, if you run in check mode, oh wow, that's hugely legible. Großartig. Yeah, what you can see is basically what PHPCS fixer found, all the issues. In this case, it was some unused function include or function requirement. This will also keep your code a bit more healthy. So, next topic, and I think I'm a bit slow today, so I need to speed up. Handling dependencies. The problem is Composer is great, but all the dependencies that you include, and in PHP we're actually on the safe side because we just have like 100 or so in each project. With Node.js you easily have, I don't know, some 1,000 dependencies. But still for PHP, the basic questions are the dependencies secure, are they maintained, and do they fit together? From the last one is not so easily solvable with automated tools, except if the version constraints match, but are they secure and are they maintained are things that you can automatically answer. One tool is SensioLab's security checker that checks for known vulnerabilities with the versions. The downside that I found is that it uses its own database. It doesn't like just connect to CVE or something. So if there is really a brand new security issue that might take some time, it seems to work pretty well, but I don't think there's a guarantee. And for example, I had one project where the deployment failed because I forgot to do the type rate. And that was basically the output of that check that we have in the deployment pipeline. So it basically checks all your versions, and in this case, the RStream wrapper had an update in the meantime. The thing is, you need to run that on not only on deployments, but also regularly, like every night or so, to not stay unprotected if the project is not deployed for a longer time. Yeah. Mike? Or I can also repeat the question. Okay.
What we are doing is that there is PHP Composer, what's secure package, what's not, which basically consists of all packages with security issues that marks them as conflicting then.
Yeah.
And it goes similar for, I think it's Sebastian Michels that's had made it for TYPO3 as well for their TER. And if you bind these two packages in your project, it will scan, and if there are any conflicts, you cannot build because of conflicts in your package, and then you have it on every single build.
Yeah, we also have that on every single build because it's part of the deployment pipeline. But for TYPO3 extensions, I'm not sure if this actually includes TYPO3 extensions. I didn't find out. I didn't find any composer namespaces of TYPO3 extensions in there, but I only roughly checked. So as Thomas mentioned, there is also a composer package or two composer packages that basically have the same. One has the same information that this one uses, more or less, and the other one has issues or has conflicts with all TYPO3 extensions that have known security issues, or with all the versions that have known security issues. It's not like one security issue and you're totally out. They limit it to the affected versions. So this is an alternative that you can just use. Okay, so for composer dependencies, you sometimes, I don't know, for example, with PHP unit includes a lot of other packages, and if you use anything from these packages, you introduce a hidden dependency, because this dependency is only included because you have another dependency that's pretty dangerous, that can break at any time because you have no control over the required version, and also it can be removed with an update, which is why you should have a check that all the classes that you use are actually part of your required dependencies. And there is a composer package for that that checks your require section and checks all the symbols, basically classes if you do OOP, if they are part of the stuff that you required. The only downside is it doesn't work in vendor currently and is thus not usable for TYPO3 extensions and also TYPO3 projects, because nothing that we do in TYPO3 is inside, or no part of TYPO3, actual part of TYPO3 is inside vendor. They are all outside, which is pretty bad, but I guess this will be fixed at some point. And I'm gonna watch this project and also try to fix that. Yeah, find unused dependencies. The usual problem in a longer running project, the number of dependencies is growing. Some are included but not used, or they used to be used and then someone eliminated that code, but didn't remove the dependency because they were not aware that this is the last usage. So they should be found and eliminated, because every code that you deploy is basically a liability. There might be issues in there, and also it's stuff that you don't use, and just proper regular housekeeping. There is this pretty funny composer vendor name, ICANN_has_string, and they, he, she, whoever created this composer unused package that you can install globally. That's a nice thing. Composer Y is not enough because it just checks what dependency included that package. But we want to check if the code actually uses a dependency, and this is done by that package. But as well, or here as well as in the old or in the other package, this currently ignores TYPO3 extensions for whatever reasons.
Correct. With their last part,
Yeah.
because I built it in myself in version 0.56. So you just have the wrong version checked out.
I actually have version, let me check, because there's a screenshot.
It ignores
Not a version
three
number.
core packet extensions, not regular extensions.
Okay. But all TYPO3 core extensions also have the TYPO3 CMS extension.
Yeah, but they are
type.
placed on a different location, and that's why they are not sorted out the same way.
Okay.
But I'm working on that part too.
The thing is, I tried checking my I tried checking an extension, not a complete project. That was probably the fault here. But as you can see, for normal, or probably not see, for normal packages it works. I have Doctrine Debol and Nesbot Carbon, some data handling library required here. And I have one class that basically does it, or uses a database connection, which is why Doctrine Debol is marked as used, but I don't have any data handling. I didn't manage to write enough code to do any actual work in the class, which is why the Nesbot Carbon is marked as unused. And also, I require TYPO3 CMS frontend and CMS core, and for them, it's at invalid package type, and that was why I concluded wrongly, apparently, that this doesn't work. Okay, but I need to speed up even more. So testing tools. I'm just gonna skip this one because you all know that you should test. And for testing tools, okay, we've got PHP unit and Codeception. Let's just skip that because we already had that since 2009 and might get boring. So how to improve your tests? And I actually have 3 things that I think are useful and also matching composer packages for that. One is using random fake test data or fake data in the tests. The second one is mutating tests, and the third one is randomizing test execution. For the first thing, random fake data, I think an anti-pattern are hard-coded or is hard-coded input data in your tests. Like you have one name in there and some numbers, like, I don't know, 10, 20, that you test, but the problem is only this one particular case is tested. But what you actually want is testing a class of input data. And for that, you can use random test data. Like, for example, I need an integer from 1 to 200, and it's just gonna create one random integer each time the test is run. Pardon? As far as I know, well, for one, so the question was on how to reproduce the test if a test fails. This is actually a valid question. For one, you normally see the data that caused the error in the exception if you use proper exceptions. And there's also, I think, the possibility to seed this randomizer with a value. So there's one library that I personally use, this Fsaninoto, whatever, faker, that can generate all kinds of fake data types. It's even localizable, so you can have German texts in there or German names, German sounding names. It's also extensible. You can add your own stuff in there. And it's actually very easy to use. It's just one call to get an instance of the faker, and then you have multiple properties that you can just output. And I think this faker can also be initialized with a random seed, but I'm not sure about that. And that would allow you to basically have reproducible data in the tests. But I would need to check that again. Yeah, so there are loads of different types of fake data, so you can really test almost any use case, like names, addresses, phone numbers, fake text from words to full paragraphs, random numbers with ranges even, dates in every kind of format that you wish for, credit card data that looks valid. I didn't try buying something with it, but it at least looks legit. Colors, yeah, and loads of other things. Basically everything you can imagine. And usually you can also use that or you can easily build your own data from these existing data types. So that was one topic. For the second topic, mutating tests. The problem is how robust are our tests? Will a test fail if we change the code? So can we actually detect faults in the code, or are these tests more or less, or not useless, but not so useful, especially for edge cases? If I change this greater than to a greater equals, or this equals to a not equals, will that make a test fail? And this if you're looking for test coverage, I think this is actually a better metric than test line coverage. There's one tool, Infection, that also calculates an actual metric, like a number on how well your test is covered, your code is covered by the tests. This, at least from looking at it, looked pretty sound and sensible. Yeah, so how does it work actually? It runs the test suite. That's how Infection does it. The other tools might have slightly different mode of working. It runs the test suite. If all tests pass, it mutates code and then runs all the tests that cover this particular line of code. And these mutations are done by so-called mutators, and they have different classes of changes. For example, they switch a 0 for a 1 or the other way around, or switch operators in different ways. And each of these actually covers one class of bugs that you can do in your code, and that makes it makes your tests more robust, makes you write more robust tests, which is why I think it's good. So random test execution, I'm just gonna do that pretty quickly. Tests should be independent, but PHP unit by default runs them all in one process and with a fixed execution order, which is not so nice because one test might have tainted the global state so that another test or later test runs smoothly. And so they have a hidden dependency to each other. And that is just discoverable if you have a random test execution order. The slides are going to be online, which is why I'm going to skip this. So for the last topic in 1 or 2 minutes, deployment. I heard someone we had some developer days in the past that were called the TYPO3 deployment days because every second talk was about deployment. Which is why I'm not gonna talk about the boring stuff because you all know how that works. But I'm just gonna talk about 3 things in like 2 minutes. Blue-green deployments, feature switches, and data migrations. Blue-green deployments are actually awesome because you have 2 parallel life stacks, blue and green. You can call them differently, but blue and green are established names. One of the 2 stacks is live, the other one is cold, basically. If you do a deployment, that goes to the cold one, and you switch cold and live after the deployment. The nice thing about this is you have 2 parallel databases, 2 parallel file admins, blah, 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 whatever you need. So a complete rollback is possible. Not only a rollback to the previous code, but most database changes can't easily be undone. So you need to do complex operations if something fails in the database, actually. And with such a blue-green deployment, you have basically the old live version with everything in there still available and can just switch back to that. Of course, a bit bigger effort. So probably only a thing for bigger projects. Another thing is feature switches. They are also awesome because they allow decoupling deployment from turning on the feature and also allow for different strategies of rolling out features. One is only switching stuff on for part of the traffic, A/B testing, or a staged rollout like 5%, 10%, 20%, and so on. To check if the feature actually works, or just test with some key user groups and then later on roll it out for the rest of. And you can also instantly turn off a feature again in case of problems. They are actually pretty easy to implement, but in TYPO3 there's no inherent support for this. And data migrations, you know the drill. If you've ever worked with Flow, that's all in there. They migrate data, not only the schema as TYPO3 core does it. One thing is doctrine migrations. And the awesome thing is you can migrate up and down. And there's a TYPO3 integration available for that with migrations per extension. Because for one project, we actually patched the extension, and it's available on my GitHub account. So there is 1 minute, I think. No, there's actually more for questions. Thank you for listening. I hope you got at least one thing from this talk.